Hey kids, Mr. Murray here. We're talking today on Mr. Murray's Math Land about a big topic in trigonometry, and that would be reference angles. It's seemingly a small part, but a lot of problems come back to it. So first things first, let's define what a reference angle is. It's an acute positive angle formed by the terminal side of an angle in standard position and the nearest x-axis. I'm going to highlight that part because that is sometimes something people overlook. So what that means is, as we've been studying trig and we've been talking about angles in standard position, the terminal side, that would be the side of the angle that moves. It can terminate in quadrant 1, it can terminate in quadrant 2, it can terminate in quadrant 3, it can terminate in quadrant 4. So I'm just going one by one here, that if you're in an angle in quadrant 1, the reference angle would be the acute positive angle formed by this terminal side and the nearest x-axis. In other words, it would be right here. And basically you're just saying, trigonometry comes back to right triangles, and you're imagining that you would be forming a right triangle with the nearest x-axis. So just dropping an altitude there, and that angle that's formed there on the inside, that's your reference angle that you'd be using to do SOHCAHTOA or whatever on. So in quadrant 2, okay, you're right here. So the altitude, you would draw it with the nearest x-axis, and the reference angle would be right here, that acute positive angle. Basically, how many degrees are you away from that x-axis? So notice, it's right here, not here, not here. It's the angle formed with the x-axis, not the y-axis. So in quadrant 3, that would be this angle. Again, if you like to picture that, that altitude for that right triangle formed with the x-axis, go for it. But the reference angle is there with the x-axis. And similarly here, there's your altitude for your right triangle, and there is your reference angle. So your reference angles are always one of these 4 locations, just depending on which quadrant you're in. Never here, 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 or here. Right? So think of it like a bow tie, right? Because that's where your triangles are, and those are your reference angles. Okay, now let's just do some examples where we see, now that we know what we're looking for, let's just see how easy these really are. You don't have to draw a diagram, especially when you're good at these. You shouldn't have to, but it's nice to visualize and get the gist of it. So the first one, theta is 65 degrees. So that would be in quadrant 1. And the reference angle is basically how many degrees are you away from the nearest x-axis. And so that would be 65 degrees. And a lot of times we'll represent this with a theta prime. That's what the apostrophe is called there. Theta prime, the reference angle, is 65 degrees. Hey, when you're in quadrant 1, it's just whatever that acute angle is. Now, example number 2, theta is 140 degrees. So we're going past 90, but not as far as 180. So we're going to be in quadrant 2. So 140 doesn't have to be drawn to scale. We'd be about there, say, right? That's 140 degrees. This is 180 degrees. Your reference angle is right here. How many degrees away are you from that nearest x-axis? And that is going to be 40 degrees. So, if you don't know how I just got that, you're doing 180 minus 140, and that's going to leave you with 40 degrees. Okay, and so that's really what's going to happen anytime you're in quadrant 2. If you want to find the reference angle, you're always going to do 180 minus that angle. So that'll tell you how far you are away from there. So example 3, we are more than 180, but less than 270, so we're in quadrant 3. Right, there's 180, there's 270, so 210 be something like that. And the reference angle is right there. How many degrees away are you from the x-axis? And so that would be, we're 30 degrees away. So in this case, what we're doing is we're doing 210 minus 180, just to see how far past 180 we've gone, essentially. So if you're in quadrant 2, 180 minus the angle. If you're in quadrant 3, the angle minus 180. Example 4 here, 300 degrees. We're bigger than 270, but less than 360. So we are in quadrant 4, right? This is 270, and this is going 360 degrees. Would put you, one complete revolution. So 300 degrees is going to be about there. But the reference angle, bear in mind, is right here with the x-axis. How far away are we from the x-axis? And so to get that, you want to say how many degrees are you away from 360? So 360 minus 300, and your reference angle is 60 degrees. There we go, right? Always acute. Your answer should always be acute and always positive. And number 5, how about when we have a negative angle? That's no problem. The negative angle just tells you you're going in the opposite direction, going clockwise. So 100 degrees in the negative direction, just keep in mind that this would be negative 90, this would be negative 180, so negative 100 is going to put you in quadrant 3. Be right about there. And your reference angle is still, as always, how far away are you from the nearest x-axis? So when you're in quadrant 3, you're talking about that acute angle right there. And it's always acute and always positive. I don't care if the original angle is negative. You're imagining a right triangle that's being drawn, that's stationary, so there's no direction to it. It's just always acute and always positive in a right triangle. And so that would be 180 minus 100, the difference between the two. And so that would be 80 degrees. Okay. And lastly, how about number 6? Because every once in a while these kind of things come up. And 270, that's right here. And so we are at one of the axes here. When you're on the x-axis or on the y-axis, you're not in any quadrant. And so what's the reference angle? Some people would say, hey, is it 90 degrees? Because I'm 90 degrees away from either one. But that's not acute. Acute is less than 90. And the answer is there is no reference angle. This is, what we call a quadrantal angle when you're on the boundaries of the quadrants. So whenever you're on the x-axis or the y-axis, we don't consider that having a reference angle. So 0, 90, 180, 270, 360, etc. So no reference angle for those. So I figured I'd throw one of those in there. And now that you're getting the hang of it, how about when we're talking about radians? So just to keep in mind here, it's the same idea, but in radians, and you want to be comfortable with radians. You don't want to have to convert everything to degrees and then answer degrees and then convert back to radians. You really should be comfortable dealing and staying in radians the whole time. So 0 degrees, which is right there, is 0 radians. 90 degrees is pi over 2 radians. 180 is pi radians. And this is 1.5 or 3 pi over 2 radians. Every quadrant is a half pi, right? And so 360, which is 2 pi, puts you right back there, coterminal with 0. So just think fraction-wise. That's really the key that you want to think about. Picture so much not the pi, just picture 0, 1/2, 1 whole pi, 1.5 pi, 2 pi. So when you think about 2 pi over 9, focus on the fraction 2/9. Is 2/9 between 0 and 1/2? Or is 2/9 between 1/2 and 1? Or is it between 1.5? So 2/9, hopefully you don't have to think too hard about that. 2/9 is less than a half, so that will be in quadrant 1. When you're in quadrant 1, your angle is your reference angle, right? So our theta prime, our reference angle, is 2 pi over 9. That's how far away from the x-axis we are, 2 pi over 9 radians. How about when we are 4 pi over 7? Now, 4/7, 4 is slightly more than half of 7. So 4/7 is more than a half, but less than 1, right? So this is going to be more than a half pi, but less than 1 whole pi. That's going to be in quadrant 2. So if that's where my angle is, my reference angle is right here, right? The nearest x-axis. And just think fraction-wise, you know, how far away are we from making it 1 whole pi, which would be 180, pi minus 4 pi over 7, just like 180 minus the angle when it's in degrees. Well, and this is even easier when it's fractions, because what's 1 minus 4/7? 3/7. So 3 pi over 7. Radians, when you get comfortable with radians, I know it's fractions, but there's so much easier to deal with in a lot of ways. So number 9, you've got 18 pi over 13. So think about 18/13. Maybe you think of it as a mixed fraction. 13 goes into 18/1, and there's 5 left over. So 1 and 5/13. So that is certainly more than 1 pi. And 5/13 is less than a half, so that's between 1 and 1.5 pi. So you're in quadrant 3. And our reference angle is right here, right? And so we've kind of already answered our question that we're looking for. How far away from 180, or how far away from pi are we? How far past it did we go? That would be the extra 5/13. But if you have to do a whole, calculation, you can do 18 pi over 13 minus pi to see what is that difference. How far past did you go? And that would be 5 pi over 13. But see, when you get the hang of it, it's like you kind of already knew it. So just a few more examples here, and these are angles, and these are intentionally, hopefully familiar angles, because we've got 5 pi over 3, 3 pi over 4, and negative 7 pi over 6. These are from our unit circle, our classic, what I call the benchmark angles, the magic angles in the unit circle world: pi over 3, pi over 4, pi over 6. But anyway, 5 pi over 3, 5/3 is 1 and 2/3 pi. So you're more than 1 pi. 3 pi over 2, that's 1.5. And 1 and 2/3 is more than 1.5, but less than 2. So you are in quadrant 4. And what is your reference angle? So if you have to, and trust me, when you get good, you won't need to do this, but you can do 360 or 2 pi, since you're in radians, minus the angle. So 2 pi minus 1 and 2/3, or minus 5/3 if you want to make a common denominator and do it that way. But if you take away 1 and 2/3, you get 1/3 left over, aka pi over 3. So 1/3 of pi, that's the remaining bit there. For 3 pi over 4 and number 11, 3/4 is more than a half of pi, but less than 1 whole pi. So in fact, you're going to be, 3/4 is going to be smack dab in the middle between a half and 1. So there's 3 pi over 4. Our reference angle is this right here. And so you're basically saying, how far away from pi are you? So pi minus 3/4 of pi. 1 minus 3/4 is a quarter. And to do a negative example with radians, just so you're seeing it all and you're not intimidated at all by this? Negative 7 pi over 6. So we're going in the negative direction. Here is 0. Here is negative a half. Here is negative 1 pi. And this is negative 1 and a sixth pi, right? Negative 7/6. So a little bit more than 1 in the negative direction. And this is, of course, negative 1 and a half, negative 3 pi over 2. So we're going to be in quadrant 2. But the reference angle is right there with that nearest x-axis. How far past 180 did you go? And we kind of already said it. Again, it's an extra 1/6 of pi, right? If you want to do it mathematically, do 7 pi over 6 minus pi to see what's the difference, how far past did you go? And that is going to be pi over 6. Always acute and always positive. Now here's what's great about the magic angles, and that would be all the ones that are pi over 3s, pi over 4s, or pi over 6s. Those are all the multiples of 30, 60, and 45. Is that their reference angle will always be just pi over 3, pi over 4, pi over 6. So really, you're going to find it doesn't really matter that it could be 737 pi over 6. The reference angle is pi over 6. It could be 5,289 pi over 4. Reference angle, pi over 4. Don't even have to think about it for the magic angles. The other, angles when you're in radians, if it's not one of the magic benchmark angles, then yes, you might have to do a little bit of work. Notice it wasn't just pi over 7. It wasn't just pi over 13. It had the denominators, but the only time that little trick works is for the benchmark angles, the magic ones. So, okay, there was a lot of examples of reference angles, degrees, and radians. Hopefully you're feeling comfortable. If you got any questions, just ask and keep working hard.